Good evening, everyone. As I told you, I'm waiting your questions. I'm not going to explain anything, I mean, like lecture. I hope you have some questions to me and I can answer. Okay, while waiting your questions, let me to first tell you more information related to examination. It is better to record it to maybe the others wants to see. Just 1 second. It is already recording. Okay. Okay. Ready queue. Okay. Which table? Let me to show you if are you telling this one? The schedulers? Okay, we okay, let me to, you mean a 7-state diagram? Yes. Okay, I will explain how the exam will be. Or well, just 1 second. 1 second to find that diagram. Okay. Okay, I'm confused now. Abdulaziz, do you want this table or the algorithms? Okay, which algorithm? I mean, round robin algorithm. Okay. Actually, here it is not easy for me to show it. Just 1 second. Okay, just give me a few minutes to just tell everyone what kind of questions will come in the exam, and then I will try to explain round robin algorithm from the resource. Okay. Okay. So in the exam, questions will be how can I say, mixed. I mean, there will be several type of questions, like the take-home quiz. The first part, I mean, this one, I'm not going to ask questions from first question. I mean, first fill in blanks question. I told the students that they are in the class. This is actually related to another resource. But if you make a little bit research and do it, it is okay. It is fine. But I'm not going to ask this part. I will ask 10 points true false questions, but I'm not going to ask exactly the same questions. Maybe topics will be same, or maybe I change the questions a little bit. Maybe I take another point and put there. I don't know. That's why I'm always saying just study the lecture notes and test yourself by using this study questions or this kind of questions. Okay, so 10 points, true, false. 10 points, fill in blanks. This will be, again, I may ask similar questions, but maybe I will change a true false question and ask as fill in blanks. Or again, as I told you, I may ask another point from lecture notes. I explained them very clearly, actually, in the last lecture. So 10 points, fill in blanks. Okay, for the 5 and 7 state diagram, I will ask one diagram and I will say you what will happen when it is 5 state. I mean, sorry, when I will ask you when it is preemptive, when it is non-preemptive, what will happen? Actually, I will ask this kind of questions like this. Okay, like where is the process located when it is in the start state? This kind of questions. So this will be 20 points. Okay. I will ask 20 points of questions, maybe 2 questions, 3 questions, or Most probably 10, yes, 2 questions, like a kind of comparison. I mean, the difference between multitasking and multiprocessing, or sorry, or what is the difference between preemptive and non-preemptive? So this kind of things that we learned before. Okay, this will be 20 points. I mean, 10, 2 questions, 10 each of them. And you will write a few sentences related to that questions, related to that points. Okay, so it is 60. I will ask 10 points. I mean the queues, ready queue, waiting queue. Okay, so again, I may ask scenario-based questions again. And also, maybe I will ask what is the function of ready queue or waiting queue, this kind of things. Or, for example, what is the task of long-term scheduler? So 10 points, I will ask from there. So it make 70. And and 30 points for this one, applying first come, first served, shortest job first, and round robin scheduling algorithms. Maybe I will give 10 points bonus or 5-point bonus, and I will give 35 points or 40 points for this question. Okay, so in this kind of question, it will be same. You will have the arrival time, burst time, and you will draw the Gantt chart, and you will find the other parts of the table. At the end, you will calculate the average waiting time, and which one is lowest. You will say this algorithm is better for this, how can I say, situation. So, of course, I am not going to ask this much. Most probably it will be, how can I say, 5 or 6 processes. So totally, your examination will be 10 or 100 or 105 or 110. So that's it. By the way, preemptive and non-preemptive. CPU bound, input-output bound. I mean, process control block, the functional process control block, models. Also, I'm not saying that I'm going to ask everything from this paper. So study your lecture notes. I mean, especially for the true, false, fill in blanks, and explanation questions. I may ask different questions, not completely different, of course, but some questions may come from other things. For example, swapping, or what else? As I told you, multitasking, multi-programming, multiprocessing. These kind of things are very important, and we use them so much. So actually, we have a lot of topics, but you don't need to study so many things. I already told you in the class. If you attended last class, I explained very clearly. If you didn't, ask to your friends that they attended. Okay, don't ask me. Okay, I'm going to explain round robin. Let me to write that. Let me to write that here. Okay. Okay. 10 fill in blanks questions and okay. And okay. Process life cycle, 7-state diagram. It will be 5 questions. Each of them will be 4 points. Or maybe I may ask more questions if any of them are easy. Maybe let's say, okay, let's think it like that. It may be, for example, 7 questions and some of them 2 points, some of them 4 points. Anyway, I forgot, just 1 second. What was I was saying? The schedulers. let's say 5 questions and 2 points for each. Of course, these questions will be just, you can explain them in one sentence or a few words, okay? It does, you will not need to just write several sentences. What's one sentence?
Yes,
Hello, yes.
yes. With this diagram, will we draw or you will draw? You tell us to explain it. I didn't get it clear. The state diagram, the process life cycle.
Okay, in
No,
7-state diagram, I am not going to tell you to draw it or to write the names of the each of these states. I'm not going to do it. Okay, I will ask scenario-based questions, like I asked in the take-home quiz. Okay, so
okay.
is it okay or?
Yeah, it's okay. Thank you.
Okay. So let me to finish this 20, 40, 60, 70. Um, um, let's make it, I think if I give 35 points for that, it will be fair. So this one will be 10 points. This one will be 10. And this one will be 15 points. Okay. So totally, our examination will be 105 points. So 5 points will be bonus. So this will be your examination question types. Okay, I am writing very, very big. Calculators will not be allowed, but you can give, if you need, you can bring just that dumb calculators that you can buy it from Mr. Pound, okay? Normally, if it is not easy for you to calculate something, actually, I'm not going to ask something that you will do more than addition, okay? If you, for example, find the answer of the question 27/7, I don't want you to give me exact result. It is okay, okay? So calculators are not allowed. Smart watches are not allowed. Do not hide your mobile phone. I mean, just you have to close and keep your mobile phone away from you, and also lecture notes. So please know these things. There will be separate invigilators for each exam. So I gave you study questions. I gave you everything. Please study and come to exam. Okay, it will not be hard for you. Okay, so Okay, list the sections that we will be taking the exam. Okay, you can ask your friends if you didn't come to class. You can ask your friends. I spent nearly 1.5 hours to explain one by one, and also you can understand what kind of questions will come, or what are the important topics by just checking. I said you first question is excluded. Okay, I'm not going to ask anything from first question. The other questions, think it will be asking about multitasking, what can I say, batch operating system, for example, about the history of computers. So it is very clear what kind of questions we are asking. Okay, so if you didn't attend the lecture, please ask to your friends that they attended. I'm not going to explain from the beginning. I also excluded some points.
Excuse me, sir.
Yes.
Will you ask like a question from the assignment?
No. I'm not going to ask from the assignments.
Okay,
I
okay.
already wrote them. So there is nothing. Actually, you mean the installation of operating system? Yes. Hello.
Yeah, I'm getting you.
Do you mean the installation of operating system to
Yes,
virtual?
yes.
No, I am not going to ask. Also, if I don't remember wrong, I just extend the deadline after the midterm. So I'm not going to ask. If I
Okay, sir.
do it, I have to tell you. Okay. Okay. So I'm thinking, how can I explain round robin? Let me to 1 second. It is very, very hard to explain from here. Just 1 second to open OneNote. So if the time is finishes, I will just open the meeting by using same link. By the way, okay, can you mute your microphone, because we can. Okay. So yes. I'm going to explain it from here because it is step by step explaining this algorithm. Round robin. So round robin is a preemptive version of first come, first served. So our aim is actually to just take into consideration the first coming process, but on the other hand, for example, here, because of we are imitating a kind of multitasking algorithm, it is just switching between the processes between some time quantum. So this is the difference between first come, first served. Okay, in the question it is saying that the time quantum is 4 units. Okay, which means in each 4 units, the CPU will remove the process from execution, one process, and take the next process for execution. So let me to start. Okay, here we are using ready queue with the Gantt chart. While we are drawing Gantt chart, we are using the ready queue. Okay, let's check. Because of it is a kind of first come, first served, I mean preemptive version of it. We will check first the arrival time. Okay. What did we say? CPU should be always busy. That's why when a process arrives to the ready queue process, if there is no other process there, CPU will take it immediately. So while process 1 arrives to the ready queue in time 0, I mean when the time is 0, CPU will take it and start to execute. Okay, how much time? 4 nanoseconds. Okay, but the burst time of it is 5 nanoseconds. Let's check the ready queue first. This is just showing how much time it will execute. Okay, not to forget, it is putting also this one. I used another method. You can choose any of them. So P1 is in ready queue. How much time it will execute? We will show it in Gantt chart here. So P1 will be in Gantt chart. We will show that P1 will be execute 4 nanoseconds. So P1 have 1 more nanosecond for execution. So what does it mean? We have to put P1 in the ready queue again. Okay, but think about that. The process is executing P1 4 nanoseconds. When the time is 4, and we have to put it back to the ready queue because still have 1 minute, 1 nanosecond to execute. In this case, we have to check which processes are in the ready queue. So when time is 1, process 2 is arrived. When time is 2, process 3 is arrived. When time is 4, process 3 is arrived. And when time is 5, process 4 is arrived. So we can put back to the queue after these 4 processes. Okay, so when time is 4, these 4 processes are already in the ready queue. So we have to put process 1 after these 4 processes. So it will be like that. As you see, process 2, process 3, process 4, and process 5 are in the ready queue. So after the process 5, I will put process 1. Okay. The next one is what? Process 2. So I made it in order. So process 2 will be executed. How much time? 4 nanoseconds. Okay. So it will execute process 2 4 nanoseconds. And when the time is 8, let's check if there is any other processes arrived or process arrived. Only one process remains. By the way, we know these things, but normally in real time, CPU does not know which process will arrive to the ready queue. So that's why we are not counting the processes that are not arriving to ready queue, arrive to ready queue yet. So here, when time is 6, process 6 is arrived. So when we want to put the process 2 back to the ready queue, it will put after process 6. So here, when time is 6, process 6 is arrived. At that time, actually process 2 was executing by the CPU. Now, that's why when time is 8, process 2 has remaining 2 nanoseconds for execution. So we have to put it back to the ready queue, but we have to put it after P6 because P6 is arrived when time is 6. So after you have this one, after all the processes are arrived to the ready queue, only thing you need to do that you will execute them one after the other. And if one of them is more than 5, you will put it more than 4. It needs more time. You will put it at the end of the ready queue. So I am connecting again to finish this question.